All right, we're going to continue with the test review here with number 8. We're going to solve absolute value inequalities. I've rewritten the notes for the couple of different cases of absolute value inequality problems. This does not include the exceptions of when you have no solution or all real numbers. So number 8, again, first thing we need to do on this problem is get the absolute value by itself before we determine what type of problem we've got here. So I'm going to add 8 to both sides, running out of space, so I'm going to do the rest of the work down here. And then divide both sides by 3. So the absolute value is going to be by itself. Sorry, divide both sides by 2, and we get 3. So this is case 1 problem. It's a less than problem. It's not less than a negative number. So we know the setup when we split this into 2, it's going to be less than 3 and greater than negative 3. Subtract 2 from all 3 sides, and we've got our inequality answer. And then we want to graph this on the number line. These are open dots because it does not have the or equal to symbol. And then we just shade everything in between. If you want to make it a squiggle so it shows up, that's a good idea too. All right, number 9. Absolute value is by itself. If it's helpful, rewrite this problem as the absolute value of x minus 4 on the left-hand side. But remember, when you do this, we're not really doing anything mathematical. We're just reorienting the problem. So this is a greater than problem. It's not greater than or equal to just a negative integer. So that means this is not an exception case. So there's one inequality. The other one is going to be same format, except the sign flips, and we're taking the opposite of that expression, 4x minus 1, and then basically just solving both of those inequalities for x in this problem. So a number of different ways to do this. I'm going to subtract x from both sides. And then I'm going to add 1. Got to be careful here. We're dividing both sides by positive 3. So we did not divide both sides by negative, so the sign does not flip. And on this other side, distribute the negative 1. We're going to combine our x's. Again, a couple of different ways to do this. I added 4x to both sides. Then I'm adding 4 to both sides. So here's our answer. X is less than or equal to negative 3 or less than or equal to 1. So of course, when we graph that, 1 goes here, negative 3 is somewhere right about there. These are both solid dots. And then let's think about this logically just for a second. If we shade everything to the left of negative 3, and we shade everything to the left of negative 1. So instead of writing less than positive 1, instead of writing our solution in this form as an inequality, really we want the solutions of the numbers that are less than negative 3 or less than or equal to 1. So for instance, the number 0 is a solution. While it's not less than negative 3, it does make this part of the inequality true. So our solutions to this problem are actually anything less than or equal to 1. And you can check that by just taking a number. Let's take the number 0, for instance. And if we substitute 0 back in for x in this problem, does it work? Well, the left-hand side is going to give you a -1, and the right-hand side, 0 minus 4, is -4, but the absolute value is +4. -1 is less than +4, so that tells me this solution right here is actually the most condensed form of the solution to this problem. Number 10, add 2 to both sides. So we get the absolute value of x plus 4 divided by 2 is less than 10. This is a less than problem. So the setup, that's not less than a negative number, so it's not no solution. That's the setup. We want to solve for x, so we're going to multiply everything by 2. And then just subtract 4 from all 3 sides, and we've isolated the x. So I'm going to estimate quite a bit, -24, somewhere over there, +16, somewhere over here. And they're both open dots, because there's no or equal to symbol. There's our solution as an inequality and graphically. And then number 11, subtract 8 from both sides is going to be a quick one. We're going to get the absolute value of x is greater than a negative number. Distance is always 0 or greater. Distance cannot be a negative number. So distance is always greater than a negative number. So our solution here is all real numbers. And then we're just going to shade the entire number line. No matter what number you substitute in for x in this problem, it would make the inequality true. Last one of these inequalities, it says Sally and Jane are following a problem together. Sally wants to go through the steps to solve the problem algebraically. Jane tells her that's not necessary because the answer is obvious. So what is the correct solution? So there is a little bit of work. So they're both a little bit correct here. Technically, before you can get the answer, you need to divide both sides by 2, although probably a step you could have done quickly in your head. Absolute value cannot be a negative number. It cannot be less than a negative number. So the answer here is no solution, or you can write it as the empty set. Piecewise functions. So number 13, our boundary line for this first function is at -4. So I'm going to go and draw my boundary line right here. For this particular problem, we want just the piece that is less than +4. This is a horizontal line at -5. It has the or equal to symbol, so that means it's a solid dot. Other function, same boundary line, except it's going to exist on the right-hand side of the boundary line. We're going to start at -1. The slope is -1/2. So from that point, we're going to go down 1, right 2, down 1, right 2. This will be an open dot. The rest will be closed dots. It's only on the boundary line where it's an open dot. And that's our answer. All right, so the next section, there are 3 pieces So this first piece, boundary line at -1, and it's everything less than or equal to, which means there's a solid dot. We're going to shade everything to the left of this line. So we're going to start at point +2, and the slope is -1/1. So that's either down 1, right 1, although going down 1, right 1 is going to take us on the wrong side of this boundary line. So we need to go up 1, left 1 instead. So there's the first piece. I'll erase those points. The next piece is in between at -1 and +2. And this is just a horizontal line at y=1. So open dot here, open dot here, and then connect them. Here in a second, when I erase that boundary line, you can really tell those are open dots. And then the last piece, we want the piece, this is going to go to the right of the boundary line, 2x - 3. This is going to start down here at -3. We're going to go up to right 1, up to right 1. So here the dots overlap. So it's going to end up being a solid dot. The solid dot kind of overtakes the open dot that's already there. And there's our piecewise function. All right, number 15, the model equation for the height of a projectile over a course of time. So remember, rate of change is ultimately what they're after on all these problems. Rate of change is slope. So it's y2 minus y1 divided by x2 minus x1. So you've got to figure out, you've got to get an xy ordered pair for each of these questions. So they don't give us a table in this particular question, but they do give us the input value. They give us 0.5 and they give us 1.25. So we can sub in 0.5 in for t here in both places, and it's going to give us an output. That's what we need to do first to establish the rate of change in this problem. So I got 28 when I plugged in 0.5 for t, and then I'm going to plug in the other x coordinate 1.25 for t, and figure out the output value at 1.25 seconds. That's at 55. And now I can find the rate of change. So subtract the y values. Rate of change is going to be whatever 55 minus 28 over 1.25 minus 0.5 is. So the rate of change is positive 36 feet. I think it's feet. Does it say? I don't see. So we're just going to say 36 feet per second. And that should make sense that it's positive because the first value was 28 at 0.5 seconds, and then it went up after 1.25 seconds. You're doing the exact same thing on 15b, except this time you find the rate of change from 1 to 3 seconds. So same thing, plug in 1 for t, see what it spits out, then plug in 3 for t, see what it spits out. And it's kind of a weird one because after 1 second, the projectile is 48 feet in the air, and then it reaches its highest point and comes back down. So the rate of change here is 0 feet. We only have to use the formula 0 feet per second. Probably will not happen like that again. The rest of these review questions, I'm going to give you the answers here in just a second. If you need to see a video, Unit 1 video, I went over these problems. They will show up on the next test. So if you do not know how to do these, watch Unit 1 test review video. But here are the answers to the rest. All right, there's 16 through 18. Pause the video now. I'm going to move on to the last section. And of course, these answers are on the answer key